everybody, and welcome back to Nick's Algebraics. So today I'm going to talk about classifying triangles. So if you don't remember what a triangle is a polygon with three sides. And triangles can be classified in two ways, by their angles or by their sides. So first we're going to start off with classifying triangles by their sides. And they can be classified according to the number of congruent sides they have. So first, let's start off with a scalene triangle. So scalene triangles have no congruent sides, kind of like this. So as you can see, all the sides have a different length. So these have no congruent sides. And next we have isosceles triangles. So isosceles triangles look something like this. So that means they have at least two congruent sides. And last but not least, we have equilateral triangles. So equilateral triangles have three congruent sides, so it looks something like this. So as you can see, all three of the sides have the same length. And you might be wondering, since an isosceles triangle has at least two congruent sides, and an equilateral triangle has also at least two congruent sides, it has three congruent sides, that means an equilateral triangle is also isosceles. An equilateral triangle is basically a special kind of isosceles triangle. So now that we classified triangles by sides, now let's classify triangles by angles. So first we have an acute triangle. So these are triangles with three acute angles, so it looks like this. And next we have a right triangle. So this is a triangle with one right angle. And to indicate that the angle is right, we use this little box like that. And next we have an obtuse triangle. So this is a triangle with one obtuse angle, like this. And last but not least, we have an equiangular triangle. So this is a triangle with three congruent angles, like this. So as you can see, an acute triangle has three acute angles, and an equiangular triangle has three congruent angles that are also all acute. So an equiangular triangle is also an acute triangle, just a special kind of an acute triangle. And I don't know if you noticed, but all triangles have at least two acute angles. So an acute triangle has at least two acute angles. A right triangle has two acute angles, an obtuse triangle has at least two acute angles, and also an equiangular triangle has at least two acute angles. But the third angle is used to classify the triangle. So if the third angle is also acute, it's going to be an acute triangle. If the third angle is a right angle, then it's a right triangle. If the third angle is an obtuse angle, then it's an obtuse triangle. And if the third angle is congruent to the other two acute angles, then it's an equiangular triangle. And when you're classifying triangles, you want to be as specific as possible. So while a triangle with three congruent angles is an acute triangle, it's more specific to classify it as an equiangular triangle. Okay, so now let's do an example. Classify triangle PQR as acute, equiangular, obtuse, or right. Explain your reasoning. So they show us this picture of a triangle and it's made up of more triangles, specifically right triangles. But we want to look at the triangle as a whole. We're looking at triangle PQR right here. So what we have to do to classify this is let's look at the angles. We have this 45-degree angle right there. And we have a 31-degree angle right here. And we have this entire angle right here. So let's find the measure of that angle. So the measure of that angle is going to be 45 degrees plus 59 degrees. So that equals 104 degrees. So that angle right there is going to be one huge 104-degree angle. And that's an obtuse angle. So since triangle PQR has one obtuse angle, then that means it's an obtuse triangle. So now let's do another example. So this problem is more focused on the sides of the triangle. So it says classify a triangle OPQ by its sides, then determine whether it's a right triangle. So just remember that you can't assume that it's a right triangle. You have to demonstrate it. So the angle that looks pretty right to me is this one right there. But we have to prove that it's a right angle. So to do that, we have to look at the intersecting segments. So we have to look at the slope of segment OQ and segment OP. And if those segments have negative reciprocal slopes, then we know that they're perpendicular and intersect at a right angle. So to find the slope of these segments, we have to look at the rise and the run. So for segment OQ, let's pick two random points. Let's pick easy points like the origin and this point right here. So the rise is 1 and the run is 2. So that means the m, which is the slope of segment OQ, is going to be 1 over 2. That's the rise over run. And now let's do the same for segment OP. So for OP, we're going to pick this point right here and this point right here. So that means the rise in this case is we're going down 2, so it's negative 2, and we're going to the right 1. So that means that the slope of segment OP is going to be negative 2 over 1, which is negative 2. And as you can see, 1/2 and negative 2 are negative reciprocals, because if we have 1/2, take the reciprocal of that, so that becomes 2 over 1, and then make it negative, you get negative 2 over 1, which is negative 2. So since their slopes are negative reciprocals, then that means we know that they're perpendicular, which means that they intersect at a right angle. So now that we know that triangle OPQ is a right triangle, now we have to classify it by its sides. We have to figure out if it's scalene or isosceles or equilateral. So we know that in a right triangle, there's something called the hypotenuse, which is segment PQ right here. And what that means is that the hypotenuse is the longest side of a right triangle. So we know that segment PQ is the longest side. So that means it's not an equilateral triangle because one of the sides is going to be longer than the others. So now we're left with either isosceles or scalene. And just by looking at it, segment OP is much shorter than segment OQ, just because it's on a coordinate plane, and you could look at the distance. So since those two segments are different, and the third segment, PQ, is the longest side, then that means all the sides have different lengths. So that means there are no congruent sides, which makes this a scalene triangle, specifically a right scalene triangle. So now let's do another example. If point M is the midpoint of segment JL, classify triangle JKM as equilateral, isosceles, or scalene. Explain your reasoning. So triangle JKM is right here, and we have the length of one segment, and we need to figure out the length of the other two segments so we can classify it. But in the problem, it says point M is the midpoint of segment JL. So segment JL is right here, and we know that M is the midpoint of this segment. So that means it's cutting this segment into two congruent segments. So that means that JM is going to be equal to ML right here. They're going to have the same length because the midpoint is cutting this in half. And we also know that ML has the same length as KM right here. So now we can figure out the side lengths. So since this entire segment is 1.5, then that means JM must be 0.75 and ML must be 0.75 because they're the same length and they have to add up to 1.5. So we just do 1.5 divided by 2. And we also know that this is 0.75 because it's equal to ML. So as you can see now, triangle JKM has three side lengths of 0.75. And since each side length is the same, then that makes it an equilateral triangle. So let's do another problem. Find the measures of the sides of triangle ABC. So in this triangle, we see that AC is equal to CB because there's the tick marks there. So what we can do to find x and the measures of each side is to set them equal to each other. So we know that 4x plus 1 is going to equal 5x minus 0.5. So first, let's get rid of the terms with the variable in it. So I would subtract 4x on both sides. So you're left with 1 equals 5x minus 4x, which is 1x, which is just x, minus 0.5. So then we would add 0.5 to both sides, so we would get 1.5 equals x. But remember, it's not asking for x, it's asking for the measure of the sides. So to find the measure of the sides, we need to plug in x. So we know that AC equals 4x plus 1. So why don't we plug in 1.5 to that, and we'll find the length of it. So 4 times 1.5 plus 1, and that's going to equal 7. And since this is an isosceles triangle, we know that AC is equal to CB. So also CB is going to equal 7. So now all we got to do is find the length of AB. So AB is 9x minus 1, so let's plug in 1.5 to that. So AB equals 9x minus 1. So let's plug in 1.5. So that's 9 times 1.5 minus 1, which means that AB equals 12.5. So we have that AC equals 7, CB equals 7, and AB equals 12.5. And that makes sense because it's an isosceles triangle. So now let's talk about interior and exterior angles. So interior angles are the angles inside a polygon. These are the angles we've been talking about. So in triangle ABC right here, the interior angles are going to be right here. So we're aware of those types of angles. We've been working with them all the time. But exterior angles are the angles that form linear pairs with the interior angles. So if you don't remember, a linear pair looks something like this. It's these two angles, let's say angle 1 and angle 2, that are adjacent, and adjacent means they have this common side. This is the common side that they share, and they are supplementary. So basically, if we extend the sides right here so that it looks like this, and extend this side so that it looks like this, and extend this side so it looks like that, then that means the angles right here are going to be the exterior angles. So now that we understand interior and exterior angles, let's talk about the triangle angle sum theorem. So the triangle angle sum theorem says that the sum of the measures of the interior angles of a triangle is 180 degrees. So basically when you add up all the interior angles of a triangle, you're going to get 180. So basically the measure of angle A plus the measure of angle B plus the measure of angle C is going to equal 180 degrees. And you probably learned this in elementary, so you're probably pretty familiar with it. And now that we know that, let's talk about the exterior angle theorem. So the exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So let's take this one at a time. The measure of an exterior angle of a triangle. So let's make an exterior angle, like let's just extend this side like this. So there's an exterior angle right there, let's call it angle 1. And we know that it's equal to the sum of the measures of the two non-adjacent interior angles. So remember, adjacent means that it's right next to each other, that it has a common side. So angle 2 right here is adjacent to angle 1 because they have this common side right here, and they're right next to each other. So that means the non-adjacent interior angles are going to be right here and right here. Angle A and angle B are non-adjacent to the exterior angles. So it's basically saying that the measure of the exterior angle, so the measure of angle 1, is going to be equal to the sum of the measures of the two non-adjacent interior angles. So the non-adjacent interior angles we just said is angle A and angle B. So it's going to equal the sum of those, the measure of angle A plus the measure of angle B. So that's basically what the exterior angles theorem says. And also, instead of saying non-adjacent interior angles, these are also known as remote interior angles. So why don't we quickly prove the exterior angle theorem? So we know that in triangle ABC, the interior angles add to 180. We know that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180, because that's the triangle angle sum theorem. And we also know that the measure of angle C plus the measure of angle 1 also equals 180, because it's a linear pair right there. They're supplementary. It forms a straight line. So what we can do with this information is for 180, I can substitute measure of angle 1 plus measure of angle C. So as you can see right here, for 180, I just substituted measure of angle 1 plus measure of angle C. Because these both equal 180, I can just set them equal to each other. And now as you can see, the left and right side both have measure of angle C. So what I can do is subtract that from both sides. And so you're going to be left with measure of angle A plus the measure of angle B equals the measure of angle 1. And there you go. We proved the exterior angle theorem, because measure of angle A plus measure of angle B equals 1, just like we said it earlier right here. So now let's do an example. Find the measure of angle JKL. So as you can see, we have this lady. She's doing a triangle pose. She's doing her yoga. She's working out. And we want to find the measure of angle JKL right here. This angle right here. So to do that, we need to use the exterior angle theorem. So the exterior angle theorem tells us that the measure of angle L right here plus the measure of angle M right there is going to equal the measure of angle JKL, which is the angle we want to find. Because remember, the two non-adjacent interior angles is going to equal one of the exterior angles right there. So we know that the measure of angle L is x degrees, and the measure of angle M is just 50 degrees, and the measure of angle JKL is 2x minus 15. So now let's solve for x, and we could plug in our solution to 2x minus 15 to find the angle. So what I would do is subtract x from both sides. So you're left with 50 equals 2x minus x, which is just x minus 15. And you could add 15 to both sides, and you get 65 equals x. But remember, we're not looking for x, we're looking for the measure of angle JKL. So why don't we plug in 65 to x and figure that out? So we know that the measure of angle JKL equals 2x minus 15 degrees. And we know x is 65, so let's plug in 65. And 2 times 65 minus 15 is 115 degrees. So that means the measure of angle JKL is 115 degrees. And that makes sense because it looks like an obtuse angle. And we figured this out by using the exterior angle theorem. So now let's talk about corollaries. So a corollary is a theorem that can be proved easily using another theorem. So an example of this is the corollary to the triangle angle sum theorem, which says that the acute angles of a right triangle are complementary. So as I said earlier, the triangle angle sum theorem says that the measures of the interior angles of a triangle add up to 180. So basically the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. The corollary to this says that the acute angles of a right triangle are complementary, which means that they add to 90. So let's say that triangle ABC is a right triangle. We can make angle B the right angle here. For the measure of angle B, we can substitute 90. So the measure of angle A plus 90 plus the measure of angle C equals 180. And if I subtract 90 from both sides, I'm going to get that the measure of angle A plus the measure of angle C equals 90. And those are the two acute angles in the right triangle. And as you can see, they're complementary because they add to 90. And we easily prove that using the triangle angle sum theorem. So that's why it's called the corollary to the triangle angle sum theorem. So let's do an example with this. Find the measures of each numbered angle. So let's start with finding angle 1. So we know that based off the corollary to the triangle angle sum theorem that the acute angles in a right triangle add to 90. So in this right triangle right here, we know that the measure of angle 1 plus 52 is going to equal 90 because those are the two acute angles in this entire right triangle here. So if you subtract 52 from both sides, you'll get that the measure of angle 1 is 38 degrees. So now let's find the measure of angle 2. So now we have to look at this triangle right here. And based off the corollary to the triangle angle sum theorem, we know that the measure of angle 2 plus 38 also equals 90 because those are the acute angles in this entire triangle right here. So if you subtract 38 from both sides, you'll get that the measure of angle 2 is 52. So it's a 52-degree angle. So now let's find the measure of angle 3. So since we know that this is 52 degrees, and we know that the measure of angle 2 plus the measure of angle 3 equals 90, because there's the right triangle symbol right there, which means that it's a right angle. So if you substitute 52 for measure of angle 2 plus the measure of angle 3 equals 90, we can subtract 52 from both sides, and you'll get that the measure of angle 3 is 38 degrees. So now let's find the measure of angle 4. We know that this is a right triangle right here because this part right here is a straight line, which means it adds to 180. So since this part is 90 right here, then that means this part must be 90 as well, because 90 plus 90 is 180. So since we know it's a right triangle, we can use the corollary to the triangle angle sum theorem. And we know that these are the two acute angles right here, so they're going to be complementary. So 38 degrees, which is the measure of angle 3, plus the measure of angle 4 is going to equal 90. So when you subtract 38 from both sides, you'll get that the measure of angle 4 is 52 degrees. And there you go. Now let's do our final example. Find the measure of each acute angle in the right triangle if the measure of one acute angle is 8 times the measure of the other acute angle. So it looks like we have this right triangle, something like this, and it wants us to find the measure of each acute angle in this right triangle. And it's saying that the measure of one acute angle is 8 times the measure of the other acute angle. So that means one of the acute angles is going to have a measure of, let's say, x, and the other acute angle is going to have a measure of 8 times that. So it's going to be 8x. And now we have to find the measure of each acute angle. So we can use the corollary to the triangle angle sum theorem. So we know that x plus 8x is going to equal 90 because the acute angles in a right triangle are complementary. So x plus 8x is 9x because this is basically 1x plus 8x. And when you divide both sides by 9, you'll get that x equals 10. So that means that the small acute angle is 10 degrees, and the large acute angle is going to be 8 times 10 degrees, which is 80 degrees. And that's it for today's video. Check the description for worksheets with the answer key. See you later.